I do not know.
I don't know. No.
Ocean acidification is where you're changing the pH levels in the ocean, where the ocean should be relatively neutral. Its salinity isn't going to change, but just the pH of the ocean water itself is changing. So it's probably getting greater into the acid range rather than being neutral, or even basic in some ways. It changes the living habitat for the organisms in it.
Historically, oceans have always been slightly basic with a pH of 8.16. However, it is a known fact that there has been a significant increase of carbon dioxide in the past century, which has altered the acidity of the ocean dramatically in a short period of time. After global warming, ocean acidification is the second carbon dioxide-related problem in the world. The ocean absorbs a third of the carbon dioxide released from burning of fossil fuels. In only the last 250 years, the ocean has absorbed approximately 530 billion tons of carbon dioxide, causing a 30% increase in the acidity of the ocean. This is the largest percent increase in ocean acidity in 20 million years. This large amount of gas entering the ocean forms an acid, which in turn decreases the pH level of the ocean. The pH levels themselves aren't the scary part, but the rapid rate of change is what scientists fear the most. With such a rapid change occurring, fast action will be needed to stop it. When carbon dioxide mixes with seawater, it results in carbonic acid. This causes an increase in the release of hydrogen ions into the solution. When hydrogen ions in a solution increase, it means that the substance is more acidic and has a lower pH. This process also generates bicarbonate.
Ocean acidification leads to a reduction in the amount of carbonate ions in the water. Many marine animals need carbonate ions for the calcium carbonate required to form skeletons and shells. This will affect their development and ability to reproduce, ultimately threatening their populations. Species under the most immediate threat include corals, crabs, lobsters, clams, and oysters. Falling numbers of less well-known species like pteropods, tiny swimming snails, have significant effects further up the food chain. Pteropods are important sources of nutrition for many types of fish, whales, and birds in polar and subpolar regions. The effects on corals, already highly sensitive to their environment, are particularly concerning since 1/4 of all marine species depend on coral reefs for homes, nurseries, feeding grounds, and spawning sites. This shift in the natural balance of the ocean's chemistry will have major adverse effects on tropical as well as cold water corals, and the loss of many coral species will negatively impact a variety of marine life and ocean-dependent economies, such as fishing and tourism. Further declines in fish and shellfish stocks will impact an important source of protein for millions of people. In 2006, fish provided more than 2.9 billion people with at least 15% of their average animal protein intake.
We're out of time.
Ocean acidification is impacting Hong Kong as I speak. It will affect the seafood we eat, the waters we swim in, and the air we breathe. If we don't find solutions soon for this problem, we will destroy our oceans permanently and lose many valuable ecosystems. The most logical and long-term solution to ocean acidification is to decrease our amount of carbon dioxide. Another solution would be to have better management of land that generates organic waste that adds to acidification. Also, restricting diving in some of the most fragile coral reefs could help them stay healthy. Some of the main contributors of CO2 in the atmosphere are cars, buses, and airplanes. Instead of driving so many cars that consume a lot of gas, we can all switch to hybrid cars. Or we can use a different source of fuel, such as biodiesel. We can also make airplanes more energy efficient. Carbon absorption projects such as the rainforest protection is another way to help fight ocean acidification. Hopefully, in time, we can reverse the damage that has already been done to these fragile ecosystems.